Hello students, welcome. Previously, lesson 5, form 3 topic 4, we were dealing with oxides of nitrogen. Specifically, we were dealing with the nitrogen 2 oxide gas. So today, lesson 6, we want to proceed to the third oxide of nitrogen, which is nitrogen peroxide gas. So the other name of nitrogen peroxide gas is nitrogen dioxide. So in this lesson, we are going to do number 1, methods of preparing nitrogen peroxide gas in the laboratory, and number 2, we are going to do the physical properties of nitrogen peroxide gas. So kindly stay with us until the end of the video. So previously we said we were having oxides of nitrogen. They were 3 in number. The first one was nitrogen 1 oxide gas, and its chemical formula was N2O. The other name of nitrogen 1 oxide was dinitrogen oxide. So the second oxide of nitrogen was nitrogen 2 oxide gas, and its other name was nitrogen monoxide. So today we are going to do nitrogen peroxide, which its chemical formula will be NO2. Remember, we said nitrogen is one of the elements that have got variable valences. So when we are dealing with nitrogen peroxide, the valency of nitrogen is 4 and the valency of oxygen is known, it's 2. So when we interchange the valency, what we are going to get there will be 2, 4. So there's a common factor we are supposed to divide by 2, 1, by 2, 2. So the formula for nitrogen peroxide will be N, we don't write 1, O, 2, like that. So let's proceed to the first part of our class. That's the laboratory preparation of nitrogen peroxide gas. And we're saying there are 2 methods of preparing nitrogen peroxide gas in the laboratory. So the first one is action of concentrated nitric 5 acid on copper tannings. So this is the setup that we are going to prepare nitrogen peroxide using the first method, that is action of concentrated nitric 5 acid on copper tanning. So here we're having conical flask. That apparatus is a conical flask, and here we're having a dropping funnel. So in the dropping funnel, we are going to put the concentrated nitric 5 acid. Then in the conical flask, we're going to put the copper tannings there here. So when the two react, what we are going to get will be nitrogen peroxide gas, and it is a gas, so it will pass through the delivery tube, and we are going to collect that nitrogen peroxide gas by downward delivery tube or upward displacement of air. This method of gas collection is called downward delivery tube or upward displacement of air. So we're saying when concentrated nitric 5 acid is added to copper tannings, a vigorous reaction takes place and red-brown fumes of nitrogen peroxide are evolved. That means the color of nitrogen peroxide is red-brown. It's red-brown in color. We are going to see that one in the physical properties of nitrogen peroxide gas. So next, let's write the equation for the reaction, and we're having there copper tanning, that's copper solid, reacting with 4 moles of concentrated nitric 5 acid, which is liquid. What we are going to get will be 3 products, copper 2 nitrate solution. What we are going to get will be also water and also nitrogen peroxide gas. And we say the nitrogen peroxide is collected by downward delivery tube or upward displacement of air, and the reason is we are told as it is denser than air. When we are dealing with methods of gas collection, there were several in number. One of them was overwater method, another one was downward delivery tube, the other one was upward delivery tube, and we are having the use of syrage and other methods of gas collections. So there were properties of a gas that makes it to be collected by those methods of gas collection. If you are dealing with maybe overwater method, the property of the gas that makes it to be collected by overwater method was the gas is slightly soluble in water. If we are dealing with downward delivery tube, the property of the gas that makes it to be collected by downward delivery tube like nitrogen peroxide is that the gas is denser than air. The other one was upward delivery tube. Like we said, oxygen and hydrogen gas are collected by upward delivery tube or downward displacement of air. And the reason was because the gas was less denser than air. If we check the diagram, we can see that nitrogen peroxide is collected by downward delivery tube. This is the delivery tube. Check the delivery tube. It is downward delivery tube. So the reason why nitrogen peroxide gas is collected by downward delivery tube is that nitrogen peroxide is denser than air. So next, let's proceed to the second method of preparing nitrogen peroxide gas in the laboratory, and that's thermal decomposition of metal nitrates. And we are saying nitrogen peroxide may also be prepared by thermal decomposition of nitrates of metals below sodium in the reactivity series. So when we go back to the reactivity series, the most reactive metal was potassium followed by sodium. So apart from potassium and sodium, the other metal nitrates can be used to prepare nitrogen peroxide gas in the lab. So such nitrates include calcium nitrate, magnesium nitrate, aluminum nitrate. We can have zinc nitrate, iron 2 nitrate, lead 2 nitrate, copper 2 nitrate, mercury nitrate, and also silver nitrate. So all those nitrates that we have now mentioned, we are told lead 2 nitrate is the most suitable nitrate or suitable metal nitrate that's used in the preparation of nitrogen peroxide. And the reason why lead 2 nitrate is most preferably used is that it is not hydrated. That means it does not contain water of crystallization. So what will happen when lead 2 nitrate is heated? Let's just go back to the chemistry of salts form 2 chapter 4 with what have we said on action of heat on nitrates. We said the more reactive metals like potassium and sodium, when their nitrates are heated, we are going to produce only two products, that is metal nitrate and also oxygen gas. When we are dealing with heavy nitrates or moderately reactive nitrates, that's from calcium all the way to copper, what we have said is that when those nitrates are heated, we are going to get three products. One of them is metal oxide, nitrogen peroxide, and also oxygen gas. Then next we said the least reactive metals, that's silver and mercury, when their nitrates are heated, we are going to form three products again. Their respective metals, nitrogen peroxide, and also oxygen gas. So that means here what we are dealing with is the heavy metals or moderately reactive metal nitrates, that's lead 2 nitrate. When it is heated, we are going to expect three products: metal oxide, nitrogen peroxide, and also oxygen gas. That's what we're saying. It decomposes to form lead 2 oxide, nitrogen peroxide, and also oxygen gas. So let us see the question for that reaction. 2 moles of lead 2 nitrate solid. When it is heated, it decomposes to produce 2 moles of lead 2 oxide, which is solid, plus 4 moles of nitrogen peroxide gas, plus 1 mole of oxygen gas. So next, let us see the setup. When lead 2 nitrate is heated, what we said is we are going to get nitrogen peroxide and also oxygen gas. So this is a mixture of gases. So how are we going to separate them? How are we going to separate them? So that means here we're having ice-cooled water, or we can use freezing mixture. So that means when the mixture of nitrogen peroxide gas and oxygen gas passes through the freezing mixture or the ice-cooled water, nitrogen peroxide is condensed and it forms dinitrogen tetraoxide, while oxygen goes on and it will be collected by over water method, as oxygen is slightly soluble in water. So that's how the two gases or the gas mixture is separated. So next we are told, note, if a nitrate containing water of crystallization is used, like maybe copper 2 nitrate, we are told the water released by the heated crystals will react with nitrogen peroxide gas formed, as nitrogen peroxide gas is soluble in water. So next we are saying the gas is produced, that's nitrogen peroxide and oxygen gas, are passed through a tube surrounded by ice-cooled water. On cooling, we are told nitrogen peroxide condenses to form dinitrogen tetraoxide. Its chemical formula is N2O4, which is a pale yellow liquid. That's the color of dinitrogen tetraoxide. And we are told oxygen passes on as a gas, and it is either allowed to escape or is collected by overwater method, as it is slightly soluble in water. So let's see this. This is a question for how we have collected nitrogen peroxide gas. So we're having nitrogen peroxide gas, 2 moles of nitrogen peroxide gas, which were red brown in color. On cooling it, or when we condense it, what we are going to get is N2O4, which is liquid. That's the nitrogen tetraoxide, which is pale yellow in color. So if we hit the nitrogen tetraoxide, what we are going to get is nitrogen peroxide gas. So this is how we have collected nitrogen peroxide gas, and the method of collecting nitrogen peroxide is called liquefaction method. It's called liquefaction method. So next, let's proceed to the second part of our class. That's physical properties of nitrogen peroxide gas. Number 1, we are saying it's a red-brown gas. Number 2, we are saying it has pungent and irritating smell. Number 3, we are saying it is denser than air. And we are saying it's 1.5 times denser than air. So number 4, we are saying it's easily liquefied on cooling, and its boiling point is 22 degrees Celsius. Then number 5, we are saying it's a poisonous gas, hence should be prepared in a fume chamber or cupboard. Then lastly, number 6, we are saying it is soluble in water, and the solubility of nitrogen peroxide can be illustrated by the use of the inverted filter funnel, which we are going to be discussing it in ammonia side. Learners, that's the end of our class today. Thank you for watching.